All right, now we're doing a quick video. I'm doing a quick video for you on 11.5, which was expected value problem. Got several different styles of problems from that section. So the first question, number 7, deals with figuring out the expected number of complaints per day. Okay, so what we're going to do is we're going to take 0 complaints multiplied by the probability of getting no complaints plus 1 complaint times the probability of only getting 1 complaint plus 2 complaints times the probability of getting 2, and so on. 3 times 0.33, 4 times 0.19, and then the probability of 5 complaints is 0.12. And we're going to just type that in and see what that amounts to. And when we type all of that in and hit enter, we get either exact, I can't remember if it's exact or approximately, I didn't write that down, but 2.98 is what I got when I did it. Okay, so that means the expected number of complaints in a day is 2.98 complaints. Okay, it's kind of a weighted average of the probabilities along that factors in the probability of each number of complaints happening. So do you see how the greater probabilities, the 26%, 33% chance, was with 2 and 3 complaints in a day? That's why after you did your weighted average, you got something that was right in that area, okay, between the 2 and the 3. All right, now problems we did that at first glance might not have seemed like expected value, but really were ones like number 8, problems that could be used to determine which project you might want to recommend that a company do. If you are going to base it on expected value, what you would do is calculate the expected value, expected profit is what it would be for each project. So we're going to calculate the expected profit for each, and then whichever one's highest, that's the one we'd recommend. Okay. So to do that, we look at how we have $50,000 profit is possible, and that has a probability of 0.6. That's like 60% chance of that happening. And then $88,000 profit, and there's a 30% chance, 0.3 chance for that to happen. And then a profit of $10,000, and there is a 10% chance, 0.1 of that happening. So we work that out, type that into our calculator and hit to enter, and that should turn out to be $57,400. Okay. Then you do the same for the other one, but this one has a little tricky part in it. See how this one was a profit, this one was a profit, and then this one was a loss. Okay. So we have a profit of 100,000 that we might make, and there's a 10% chance that would happen, 0.1. Profit, so that's a positive amount of 68,000, and the probability of that happening is 70%, 0.7. And then see how it's a loss? You can either put a minus here or put a plus but have a negative on the 20. So we're losing, possibility of losing 20,000. So that's why it's a minus. It was a loss times the probability of that happening. And when I do that, I wind up with $53,600. Okay, dollars. And so if they wanted us to base our decision based on expected values, we would go with the one with the highest expected value. So we would choose project A since it has the highest expected value. Okay. All right. Now there were problems we did that involve money and weather and games. And so I wanted to do a couple of those. One that we looked at was like the raffle situation. So here we have a charitable organization that's going to raffle a trip worth $500. Okay. 3,000 tickets are sold, and we'll use the fact they're sold $1 each in a minute. And then the question here is to find the expected net winnings for a person who buys one ticket. So first thing I usually do is I think about the fact that there's a 1 out of $3,000 chance that I would win. And if I do, the trip is worth $500. So basically it's like you're winning $500. All right, now the rest, the 2,999 other tickets are losers. Okay, you're really not going to do anything with that because they get nothing, right? So that would just be zero. So basically, the gross expected value, okay, the expected gross winnings would be found by just multiplying 1 over 3,000 times 500, and that turns out to be about 0.16. No, 0.17 if I round, because it's 1/6 and it keeps repeating. So it's 0.16666. So I rounded it to dollars and cents. All right, now for net winnings. So this would be the expected winnings or gross winnings. Okay. All right, and then it says find the expected net winnings for a person who buys one ticket. So I'm going to take the gross winnings and I'm going to subtract the cost of the raffle ticket, which was $1. And that gives me a negative 83 cents. Okay, so the expected net winnings would be a negative 83 cents. Okay. All right, another style that involved money was question number 10 type, the one like with the die that you're rolling and you get various amounts as payoffs. This one says you're paying $2 to roll a fair die, and you get $4 if you roll a 1 or a 5 and nothing otherwise. So these are the only things you can get when you roll a die. Okay, and the probability of each of them is 1 out of 6. Now, you don't do the expected value with the die like that. You wait until you put the payoffs in there. So you get, let's see, you get $4 if you roll a 1 or a 5 and nothing otherwise. So your expected value would be found by taking 4 times 1/6 plus 0 times 1/6, another 0 times 1/6. Another 0 times 1/6, then 4 times 1/6 for the rolling of 5, and then plus 0 times 1/6 again. But these are all going to be 0, right? So you really just have to type in 4 times 1/6 plus 4 times 1/6. When you do that, you'll wind up getting 4/3 or 1.333 repeating like that. Those are the gross winnings. So these are the gross winnings, expected gross winnings. So you need to take that 1.33 and you need to subtract how much you paid to play the game, which was $2. And that gives me a negative again. This time it would be a negative 67 cents. And then there were questions like the follow-up on this one. Is the game fair? No. Okay, because we didn't get a 0 for that. These are the net winnings right here. Okay, these are the expected net winnings. It should have been 0. Since it wasn't, it's not fair and it's unfair in my favor. I mean, unfair against me. Unfair against the player. Okay. Okay. All right, so we did these styles of problems. I tried to put one of each kind. Okay. Hope that helps.